Algebra 2 Honors, we're just calling this section 5.0. It is just a review of some exponent rules in practice. And so you've already should know these, but it's worth revisiting them. And I know that you'll need some extra practice on those. And so the first page of this is just the notes, and then you're on the back, you're going to be assigned just 27 through 38. You could do more if you wanted for practice. And so the product rule, when you have the bases are the same and you're multiplying, you add the exponents. So in part A, you have the same base of x, so you will just add the exponents, getting x to the 11th. In part B, your base is the same. There are both bases of 2 and you're multiplying, so you would add their exponents, getting 2 to the 6th, which is 64. And in part C here, you have bases of x that you're multiplying. This just means that you have 4 terms that you are multiplying. And you can change up the order on those, and you can multiply the x's first. And x squared times x cubed, you are going to add the exponents and then multiply the y's, and you have a y to the first times y to the fourth, so you get y to the 1 plus 4. And you end up with x to the 5th, y to the 5th. You can leave it just like that. So with the like bases, you add exponents. Quotient rule. When you're dividing with like bases, you subtract the exponents. So in part A, you have a base of x, and you're dividing, and so you end up subtracting the exponents. You get x to the 5 minus 2, or x cubed. Really, with x to the 5th over x squared, you have x times itself 5 times, and x times itself twice in the denominator, and those are canceling, and you're left with that x cubed. But that takes longer to write them all out, especially if the exponents are high in value, and so it's good to know the rule with like bases. When you divide, you subtract exponents. And so in part B, we have a base of 3, and we're going to dividing, so we're going to subtract the exponents. So 5 minus 3 gives you 3 squared, or we could write that as 9. And in part C, we're dividing both the like bases of x and y, so we can do them one at a time. We have x, and that's 2 is the exponent in the numerator, 1 is the exponent in the denominator, so we're going to have 2 minus 1 times y to the 5 minus 3. Subtract the exponents for the like bases that you are dividing, and you end up with x times y squared. 0. Any base except for 0 raised to the 0th power is 1. And so we have y to the 0 is going to be 1. 6 to the 0 is going to be 1. And since being the whole thing in here is being raised to the 0th power, it's just going to come out as 1. So any base except for 0 raised to the 0th is going to equal 1. Power rule. To raise a power to another power, write the base and multiply the exponents. So in part A, we have x cubed, and that is being squared. That's a power raised to another power. We don't have the base in there twice. It's x cubed squared. So what you end up doing is you multiply those exponents, and you get x to the 6th. Powers of powers, you multiply. So in this next one, we have 3 to the 2 times 4. You're going to multiply the 2 and the 4, and you're going to get 3 to the 8th. Or that probably just leave it like that rather than multiply it out. But if they ask you to, let's see, that is 6,561. But 3 to the 8th would probably be fine. And on the next one, we have z to the 5th raised to the 2nd. You're going to multiply the 5 and the 2, and you're going to get z to the 10th. Expanded power rule. What if you have more than one thing that is being raised to a power? Well, you need to take each individual piece and raise it to a power. And that's only if these are being multiplied. We've already had the binomial theorem or expansion of binomials using Pascal's triangle. And this is not, there's no addition or subtraction here. So we have both things being multiplied raised to the power. Then both of those terms need to be taken to the nth power. And similarly, when you have a quotient and you're dividing them. And so x divided by y, quantity to the nth is x to the nth over y to the nth. So in the examples, this is a 2 to the 1st and an a to the 1st. Both of those have to be raised to the 3rd power, and you multiply those exponents. So you're going to get 2 to the 3rd and a to the 3rd, because you're multiplying the 3 times the 1 in both cases. And then the 2 cubed, we're going to write that as 8, a to the 3rd. Part B, we have 6 to the 1st and x cubed. And both of these, you're squaring these, so multiply both of those exponents times 2. So you're going to get 6 squared, x to the 6th, or in other words, 36 x to the 6th. And in part C, a fraction here, in the denominator, that's y to the 1st. So both of these need to be raised to the 4th. So you're going to multiply the exponents. You're going to get x to the 8th over y squared. And that's all you can do with that. We don't have like basis, so we can't simplify. And in part D, 2 is to the 1st, x is to the 1st, 3 is to the 1st, and y is squared. So you've got 4 terms all being cubed. So you have to multiply all those exponents. And you're going to get 2 to the 3rd, x to the 3rd, 3 to the 3rd, and y to the 6th. Multiply the exponents. And then we should go ahead. These are small values. So 2 cubed is 8. And 3 cubed is 27. And that's how we should write that final answer. Negative exponents. Now, depending on the format, we'll treat these maybe in different orders. But the big thing is when you have x to the negative m, if you drop it to the denominator, the exponent changes in sign. The exponent changes in sign. And if you have in the denominator a negative exponent, you can move it to the numerator and make it a positive exponent. And a very handy thing to know is if you have a fraction, notice in this first, it's x divided by y, and it's raised to a negative. To make that exponent positive, you flip and make the fraction y over x. And we'll see that here in one of these examples. And then take it from there. So in part A, x to the negative 3, we'll write it 1 over x cubed. The goal will be to write it with all positive exponents. And so if I have 4 to the negative 2nd, that's 1 over 4 to a positive 2. And then we would multiply that out and make it 1/16. Now on this next one, the only negative exponent is the base of y raised to the negative 2. So we are going to leave the negative 4x to the 5th in the numerator and just drop and make it y to the positive 2, y squared in the denominator. That's the only piece that's raised to a negative exponent. So that's the only thing that's going to change. Now in part D, we have a fraction that's raised to a negative exponent. So we're going to use that property that we were talking about up here, that if I flip that fraction, then I can change the sign on the exponent to be positive. And then I can y is to the first, x is squared, so powers of powers we multiply, and we get a y cubed over x to the 6th. And we want things written with positive exponents, so we're going to leave it like that. Now on this next one, I would start by rewriting each quantity with positive exponents. So the 3y stays in the numerator and the x squared is in the denominator. And then the negative 2x can stay in the numerator and the y to the negative 3 can go to the denominator. And so as I'm multiplying those, I get a negative 6xy in the numerator over x squared y cubed. And when you are working with these, when you have like bases, you subtract the exponents. So we have a negative 6x to the, that's 1 minus 2, and y to the, so 1 minus 3. So I have a negative 6x to the negative first, y to the negative second. But because I want everything to have positive exponents, the negative 6 could just stay in the numerator, but drop that to the first and the second in the denominator. And so there you have that. All right, and then in part G, and sometimes there are some other ways that you can end up doing these. And so some different orders to this. We have a negative 2x squared y to the negative 4th. On this one, I'm going to just think that I've got all these to exponents, and when I've got them all to exponents, I can multiply all the powers. So I've got a negative 2 to the first, and I'm going to think of that. I have to remember that negative is really like a negative 1 to the first, and then a 2 to the first, and then x squared y to the negative 4th to the negative 2nd. Sorry about that. And then so I can think of that as a negative 1 to the negative 2nd, 2 to the negative 2nd, x to the negative 4th, and then y to the 8th. And a negative 1, a negative being squared is just going to be a positive 1. But I have this 2 to the negative 2nd, and that's going to end up being, let's see, I have enough room here. Sorry, my dogs are deciding to just now go kind of crazy here. And it's distracting, sorry. And so anyways, I can drop everything to the denominator, and I'm going to have to use a little space down here. So if I put it, the y to the 8th can stay in the numerator. The negative 1 will be squared in the denominator, the 2 will be to a positive squared, and the x will be to a positive 4. So everything that had negative exponents, I just dropped. And then simplify. And there you can see a negative 1 squared is positive 1, so that's going to just go away. And we have 2 squared, which is 4x to the 4th. So there we go. And then just 2 more here. And so we have a negative, notice that an exponent applies to only the factor it is directly next to unless parentheses enclose other factors. So this negative 3 squared is going to be a negative 3 times a negative 3, and it's going to be a positive 9. Or I can think of it as a negative 1 times 3 squared, and that's where you get that negative 1 squared and the 3 squared. And again, that's negative 1 squared is positive, and you get 3 squared is 9. But that is going to be just like that. But in part B, the negative is not being raised to the second. That negative, I could write it like this if I wanted to, which is the opposite of 3 times 3, which is negative 9. That is a frequently mixed up problem. And so just note that, and that's it.